So welcome back to restoration of the TF1101. In the last episode we fitted it all back together and did a first power up, and it showed a number of problems, and I said the first thing we were going to go and do is check the power supplies. So I had a good look online and I managed to find a operating service manual. I'll try and link it to this video. And in that manual it has some helpful information on the voltages that you need to measure. It also had a schematic of sorts. I say of sorts because unfortunately a portion of it was missing. The scan was not of good enough quality. So I spent some time now looking at that, what the schematic was showing, and then tracing my way through the unit, and this obviously will not focus particularly well, but I've now drawn out the complete schematic of the unit, which is going to be very helpful. Anyway, so using information on the manual, I did look at all of the voltages, and they're all pretty good. There were a couple of issues within the power supply. Looking at the schematic, I don't know whether this is a particularly early unit, in late 59 or early 60, but there were some components that were missing actually from this unit, notably a couple of dropper resistors. So I did fit those, and actually the voltages were then pretty much perfect. I didn't have to do any adjustment at all within the power supply, so that's really good news. So the next thing I looked at was I decided rather than looking at the output power, I'd have a look at the voltage and stability within the waveform on the output of the unit. So I went into the oscillator section, which is this section in here. I rechecked a whole bunch of the resistors, the values within that, and I also had a look at one of the key components of this particular oscillator, a wine bridge oscillator, which is within this unit here, and this is a very early thermistor. It's a vacuum tube, a tiny little vacuum tube, and its function is effectively to regulate the output of the oscillator against the frequency you select and the heat that builds up within the unit to stabilise the output. And there are two big resistors that are associated with this unit, and if they are out of trim, then the unit itself has trouble stabilising the output. So I had a look at those two big resistors, and sure enough they had drifted by about 20% in opposite directions, and also they were both noisy. So I've replaced both of those, and then what I'm doing now is I'm looking at the input into the first amplification stage. This is the output direct from the oscillator into V5, which is the first EF95 valve in the amplification chain. And you can see that the voltage has stabilised very well. The yellow trace is the output of the unit itself, so it's still very much low on power, but the input to the amplification stage, you can see in the purple there, is, well, pretty good. Nice sine wave. You can see that the stability has been greatly improved by changing those components within the oscillator itself. However, there is one remaining issue, and that is on the actual resistor just prior to the input to this valve. And if I now just gently tap it, and you can see that there is a great deal of instability that's introduced. So I think the next step is I'm going to change that particular resistor, and then we'll see whether or not that solves that particular problem, and then we'll go down the chain of amplification and we'll see what it looks like as we go through that. The 3 EF95s, and then that goes into the 12AU7. So I'll bring you back when I change that resistor, and then we'll have a look at the next valve in line and see what the waveform looks like from there. Okay, well, welcome back. I have changed that resistor now on the first stage of the amplifier. I've also changed the output resistor on the second stage, and it is now working perfectly. So I think this just shows the importance of just working through these sorts of things methodically. Obviously it does help if you've got the right kit, so you can measure in at different stages and taking care, because obviously of the high voltages that are in these units. But they are pretty robust, and you know, they're not as complicated as you might think. So let's have a look now. I'm going to turn it on. I'll bring you over to the oscilloscope, and let's see what we get. Okay, and there we are, a perfect sine wave. You can see that I'm on plus or minus 5 volts at the moment, so we've regained all the amplitude. It's up to 10 volts now, and it will go all the way up to its rated 20 volts. The meter is working perfectly as well. I've got full control over frequency. It's nice and stable. You might actually be able to hear the oscillator itself in the background. Actually, you can hear it. That's mainly because I haven't got the covers on, and obviously in normal operation you don't hear this. So yeah, that's another one fixed. So all in all, that wasn't too bad. A little bit of investigative work, but this one now I can button it up. I'll show you a picture of it when it's all done. I've got the cover all de-rusted now, and just sprayed a bit of primer on it so it looks a bit better. But yeah, 10-15 minutes of buttoning this back up, and then I'll bring you back just to sum up. Okay, just before we sum up, I thought it's a bit of fun just to have a look at the signal that's coming out of this Marconi oscillator. So I've broken out the HP3561A signal analyzer. This is a low frequency spectrum analyzer, really. It's got up to 100 kilohertz. And at the moment I've got it on a span of 10 kilohertz, and I'm running a signal from my Rigol signal generator on a sine wave at a frequency of 2 kilohertz. Let me just find something to point with here. And you can see we've got a peak here at, I don't know, about minus 25 dBm, that is. And you've got it's the fundamental, and then this is the first significant harmonic. This is the second harmonic. That looks like it's up at about 6 kilohertz. So a very pure sine wave. You know, very little in the terms of harmonics on this particular one. Looks like it's about minus 80 something dBm. In fact, we can have a quick look at that if I just move the marker across to it. It is minus 90 dBm. So let's have a look at what the oscillator is doing, the Marconi oscillator. So I'll switch it across now. And you can see that there is a big jump in the harmonic by about 10 dB, so this is sitting at about minus 80 dB. If I put the marker back across into peak, you know, it's still a good dB range, and I'm sure that if I spent some time and really matched components and, you know, tried to match some of the valves in here, I could get that sine wave looking a lot better. Let's just have a look and see if there's any more harmonics. We'll increase the span out to 20 kilohertz. Okay, a little bit out here at the, well, that one must be the third harmonic, is it? So not bad, but you know, nowhere near as probably as good as it could be. But still, as we've seen, a good sine wave, and for the purposes I'm going to be using these for, which is for electronic music, actually a little bit more harmonic content is going to be useful when we're looking at, well, wave folding and shaping and things like that in the future. Anyway, just a bit of fun there, just to have a look at how it is performing. Okay, well, I hope you found that useful. There's the unit there, now pretty much fully functional. As I say, you'd have to do a fair bit more work, especially with calibration, if you wanted to actually use one of these things in electronics laboratory setting. And arguably they're way too big now, really, for anything other than somebody who's trying to set up a vintage style laboratory. But for the value of them, you know, what you can pick them up for second hand, with a bit of work, a bit of care, obviously, given that they are high voltage units, and probably what, maybe 30 quid's worth of components, that's including probably one valve, one vacuum tube we had to change. Well worth it, and especially for my needs in electronic music. So in the future, I will be starting a project where I start to actually combine these units that I'm restoring. As I say, this is the fourth or fifth one now I can't remember exactly. But we're going to be building them into a format which will link with a Euro system so that we can control them. And hopefully, you know, they'll get a bit of use in the future or in live performances as well. Anyway, as I say, I hope you found that useful. Thanks for watching.